very interesting word is used, that is gossip protocol. So what happened in gossip protocol? What to do shape here? Can you pause recording for some time?
Actually, it is not recording, I think.
Okay. Okay. Just take an example like this are 4 servers with you. This is S1, this is S2, this is S3, and this is S4. So these all are connected with each other. Okay. Like all these 4 are connected to each other. Okay. So this is I have already explained during the first part, that is our data partition. That all these are working as a cluster. So before going inside to the gossip theorem, gossip protocol, we have any questions to ask or any doubts?
Yeah, this gossip you are telling, like, can you explain just theory wise? This practical we are going to see. I understand theory wise, like what gossip is like. What can you explain this? What is gossip protocol?
Exactly. So before going to the theorem, the gossip protocol that I'm asked talking to, it is like we all three are sitting at a different places. So what we will do, we will after some time we will everybody check heartbeats of each other by some mechanism.
Hmm.
Okay, maybe like we keep a counter to each other's heartbeat, and we will share those things regularly to each other. Okay,
Okay.
as we are sitting at the different places, we are not seeing each other. Our heartbeat is the main thing that is keeping us all together. So how we will confirm that one of us it get offline is by checking confirming it from the at least more than one. Okay, like if we have 4 servers here, we
Hmm.
have 4 people here. The four out of 4, there should be at least 2 should mention that like Bipul is out of the system. Okay. So have I explained in layman term to you?
Yes, yes, it is clear now.
Okay. So as I said that there is a table always it works like that only. So all the servers will maintain a table with each other, and all those tables will be shared, and those table will what that carry, it carry a server address, member id, and with that member id a heartbeat rate. Okay, that heartbeat counter will increase after every some like 5 seconds, 10 seconds. Okay, so if a particular server, I have to see how to create a table. So maybe like I can draw it.
I
Make
think
it.
you can scroll it down. Scroll. This will scroll it down. Just scroll it down. This page. No, no, not this
Okay.
one. This yeah. This page can be scrolled down.
This one. Okay.
No, no, the main page. The main page. You can also scroll down and make the diagram below it. Yeah. Just
Okay.
scroll it down. It would automatically it increases it, basically. New pages are created.
Okay. Like what is the table drawing? Okay. I could not draw a table here.
Just
Can you click on plus, Kankan? In left side, there is plus.
Maybe for drawing table, I should use something else.
Okay.
okay. You can use Google Sheets then. Online table you can search. I think maybe spreadsheet is better. I think. Uh, in the bottom, yeah, in the bottom there is table lecture. Hmm.
Okay. So
S1, S2, S3. These are yeah.
you can see like these are member IDs, and here will be some counter will be there like 12. Okay. This is 1201. So they are keeping their heartbeats with them, updating, and like 06. Okay. And this is like it is updated like last at 58 or maybe 50. Okay. So so what you can see here that other this whole table will be shared among all after some time, huh? After a couple of seconds, all are sharing this and updating each other. Then what you can see that others are on the time and this server one was lagging behind by 10 seconds. So this 10 second, if we get this from other more than two servers, there's that server one is like lagging behind, so that will update us that server one is offline.
Okay. So
So this way this
basically server one is dead for if it listens from suppose S1 is at 10 11 11 and basically 10 minutes behind, and S2
yeah
and S4 confirm that S1 is basically last time there is a gap of 10 seconds, so they will mark them as dead.
yeah it will mark as failed.
Okay.
So that is main part, that is failure detection. Okay. So what remedies we can do after failure detection? That is the main important part.
Mhm.
So
Okay.
we have two ways to do that. First one is simple, like a temporary failure handling, and the second one is like permanent. Okay. And in the permanent there is a, it has the theorem of Markle tree to do it. Okay. In temporary failure, what we will do? It's a simple way. Like if we say the S1 goes fail. Okay, so if S1 goes fail, so it will work in clockwise direction. So if S1 get fail, there is this is a one thing that I have to explain to you. I have missed one part. Let me add it to here. Okay, this is a special unit is there, and he is called the coordinator. So this is the main coordinator. Client will talk to him first.
I think you can keep the timestamp. It is wonderful.
Okay. So what happened? This is the client. Client will talk to the
Coordinator.
coordinator, and coordinator will take care of all of these things. That how the things will happen. It is something like is master and slave. So all those are slave. This is the main master. So what happened when S1 will go down? S There is another server. Maybe S2 will take care of all the request of S1 for a temporary basis. After that, what happened if it came back to life? S2 will write all the things back to S1. So all the servers will come to a consistency. Sure. So that is a temporary solution. Like S1 get failed, so you will write to S2, and later on S2 will write back to S1. So what happens? Sometimes this is for like small failures, like network goes off, or light got the electricity goes off for a small time. But in permanent failure, there may be like a particular data center is gone off, like Mumbai center data center gone off
Maybe
for a couple of hours. Huh?
maybe some disaster, earthquake,
Yeah,
or
because of some
tsunami.
disaster it goes off for like 1 hour 2 hours. Okay, and that time we have to handle that also. So for handling that we have a structure, a very good theorem for that, and that theorem is called Markle tree. To achieve this Markle tree, what we will do, we have a server here. Okay, a cluster of like we have 4 server cluster here. Take it as that for an example right now, as we have 4 servers, or maybe 4 plus 4 into 4, that is like 16 servers. So we will create a bucket. We will create a 4 bucket. Each will carry the similar type of uh, keys on that. Okay, like we will distribute all those keys that we have in equal buckets.
Okay.
So equal buckets, you can take an example like that. We will create now. Show that page 1, new page. I will take an example here.
If we have any diagram supporting that on the website, we can also, I think, we can use that. Would be very
Okay, okay. I have a diagram with you. I'm just creating it for you. Maybe that will help you guys. For now, I will take an example like how to compare how to compare two servers. Okay, right now. Then this whole theorem will go to the other servers too. Okay, this is like S1. This is like S1 server, and here we have S2 server. Okay, and here are we have divided that our keys in four buckets. All buckets have almost similar sizes, like each has similar number of keys in that. Am I clear till here?
Yes, yes.
Yes, Kankan.
Okay, what I will do, I have the PDF that will be more better to explain from that PDF. Yeah, it is more easy to explain here. So these are the main buckets that we have divided server 1 and server 2, and here are some keys. Those are we are keeping updated. Okay, key value pairs we keep down here. Now what happened? You can see in server 2 and server 1 there is a red mark color that there is a data mismatch. Okay, so we can visually check it out, but to detect it by machine, what we will do, we will create a hash for each of these numbers. Okay, it will return something like that. There is a hash, unique hash function. So that unique hash function can be used in both the servers. Then they will generate the same value for the same keys. Okay. Now what happened when there's then what we will do, for each bucket we will calculate another hash. So these are hashes of each bucket. Correct. Now what we will do, we will repeat this same thing recursively to the top parent, like this one. Okay, and when this is done, our complete tree is, it is a regular process that every server is doing at its place. Okay, and whenever we have to compare, we have to actually discard, instead of discarding the whole server or whole part, we have like when we have to replicate it one by one, we have to checking all those keys is very hard. So that's why we have used this Merkle tree. So Merkle tree has like a small use case, and in that use case what we will do now, as we have this hash tree with us, and to detecting the failure, what we will do, we will first check the server top levels. If the top hashes match, that means they are consistent. If top hash is not matching each other, like here we have the example, then we will drill down to the children, and are like right and left, and we will keep drilling down to the leaf node. So when we will reach the leaf node where the inconsistency is there, we will just copy paste it on that particular one.
Uh, Kankan, I have a question here. Can you go to the diagram again?
Yeah.
Zoom it out a little bit. Yeah. So here this the red color node, the leaf node, I'm talking
Mhm.
about 8, then arrow, then 1, 3, 5, 6,
Mhm.
and then corresponding to that is there is a empty red bucket, right?
Correct.
So you are saying copying the data. So you are copying empty, or you are going to copy entire 8, then arrow basically 1, 3, 5, 6 to this node in server 2, this leaf
So
node.
we will copy this entire 8 1 to this.
Okay. Then again it looks like something different. Is it basically we are going to copy it and then everything would work?
Yeah, when we will copy this 8 to here, then we again run the hash function, and the hash function will like drill up to the parent. And if the parent comes similar, then we will end our searching there.
Okay. Okay.
So it is a regular process that going on.
Okay. Okay.
Hmm. Like you can see here, to compare a two Merkle tree, start by comparing the root hash. If root hash match, both server have the same data. If root hash disagree, then the left child hashes are compared, followed by the right child hashes. You can traverse the tree to find which bucket are not synchronized and synchronize those buckets only.
Okay. Okay. Cool. Cool.
Okay. So we will not going to synchronize like all the things. We have to only check on a particular bucket. So this is what they have uh, come out with a solution, that removing a complete server or updating a complete server is very hard task. That's why they have divided everything in the bucket.
Okay. Thank you, KK. Yeah.
So this is the main reason of using Merkle tree. It is used for inconsistency detection. So it also detect the inconsistency and minimize the amount of data transferred. Okay.
Yeah.
So that's all from
Nice.
my side. Any question do you have?
No, KK. Thank you.
Okay, Bipal, do you have any questions?
No, no, no questions.
Am I that much clear?
You're that much clear.